Today, we're going to talk about distributions and a couple different kinds of distributions. So let's jump into it. What is a distribution? Well, a distribution is all of the values that you have for a variable and the frequency of these values. That might sound a bit technical and a little bit abstract or hard to follow, but we'll help to hopefully clarify that a bit more in a minute. Distributions can be depicted in tables or figures, and whenever we talk about descriptive statistics, things like the mean, the median, the variance, they're really describing a distribution. That is what the different values of a variable are and how frequently those different values are occurring. But it's characterizing that in some broader perspective, right? Like what is a typical value, right? Well, that has to do with which values occur and how frequently. When we describe distributions, there are some specific words we can use that are going to help us talk about them. So here are a few words. I'm going to jump ahead a little bit and show us a histogram. A histogram is, in fact, a depiction of a distribution. It shows us ranges of values and how frequently they occur. And this is an example of what we would call a bimodal distribution because it has two modes. What do we mean by modes? Well, we learned a formal definition of a mode before, right? The most frequently occurring value. But in this case, when we're talking about the shape of distributions, we're maybe using this term mode a little bit more loosely because we're not able to observe with this histogram exact values, just ranges of values. But we can think about what are the ranges of values that occur most frequently. And we can see right here, this is the very tallest bar. So if we want to talk about a single high point, right, in the distribution, this would be it. But we notice that there's a dip down and then a second high point right here. We could call it a local mode, right? It's taller than all of the bars around it, even though it's not as tall as this bar over here. So we could say that we have two local modes, right? In other words, it's bimodal. It has two different high points, two different modes. Um, a bimodal distribution is a type of multimodal distribution, but we could also imagine a distribution that had three high points, right? If there was a third one over here, if this continued farther to the left of the screen. So in that case, it would be multimodal and it would actually be trimodal, right? It would no longer be bimodal. But a lot of distributions also just have one mode, right? Just one high point. So you can imagine if we didn't have this extra bump in the data over here, then it would be a unimodal distribution. So just learning some terminology for how to describe distributions. Another key piece of terminology that we should be familiar with is skew. Skew describes a distribution that looks asymmetrical. And here are two different types of skew as well as a symmetrical distribution being depicted, right? So symmetrical means that we can draw a line through the middle and the two halves are going to mirror one another. That's a symmetrical distribution. And when you have a symmetrical distribution, then the mean, the median, and the mode are all going to fall at the same place. But as we can see in these two figures, when we have skew, now the mode, the median, the mean are often going to spread out a bit from one another. The idea of skew is related to the concept of outliers, which we learned before. So we can think about these observations that are sort of extreme in this distribution, right? There's these extreme values out on the right side of the distribution or the positive end of the distribution. That's why we call it positive skew. We can also call it right skew. Um, those are going to pull the mean towards the outliers, right? They're going to pull the mean farther to the right. The median is not affected by outliers, so it's not going to be pulled over to the right. So one way that you can remember that this is called right skew or positive skew is that it's pulling the mean in a positive direction or to the right of the median. Negative skew is the opposite, right? Now our outliers are on the left side or the negative end of the distribution, so we call it negative skew, and it's going to pull the mean to the negative side of the distribution. So we're going to see a mean that is lower than the median. All right, we'll get more practice in the future and come back to some of these ideas, but just introducing them right now. One other term we want to make sure that we have in our vocabulary when talking about distribution is tails. Tails refer to the ends, the right and the left end of a distribution, or the highest and lowest values. They typically describe ranges of values where there are few observations, at least if with a typical distribution that kind of tapers off on both sides. But we can also have distributions that end very suddenly, right? Like you can imagine if these bars right here were at 0, then this would be the tail, right? This bar right here, even though it's pretty high. So we would call that a very short tail. But in this case, we have a long tail on this side. You can see that this part of the distribution kind of continues on. It's very short, but it's going out to the side for a while. Whereas this side has a shorter distribution. We could find distributions that have even shorter tails, as I was describing a moment ago. But given this distribution, we would say this tail is longer than this tail. Just some examples of how we use that term tail. Okay. What about probability distributions? Before, we've been talking about distributions. Now we're going to add the term probability to the front of the distribution, this term distribution, and it's going to change the meaning a bit. In other words, up till now, we've been talking about distributions. Now we want to talk about the related but slightly different concept of probability distributions. Probability distributions are going to be related to the notion of uncertainty or probabilistic thinking. We learned before that a distribution describes how frequently every possible value for a variable occurs. That's what we just talked about on the prior slides. A probability distribution is going to be a little bit different because it doesn't describe data we've collected. Instead, it describes some random or probabilistic process and indicates how likely we are to obtain different possible values from this random process. So, in other words, the distributions we talked about on slides 2 through 5 are distributions of data that we've collected. A probability distribution is something hypothetical. It's about something that could occur and how likely different possibilities are. So again, this is rather abstract, and we're going to flesh it out with several examples. And in the next video, we're going to jump over to our appendix and look at an example looking at ER visits or emergency room visits as a key example applying this concept of probability distributions.